Pluto and Arrokoth, a glimpse into the unknown. Imagine this, a time when the best image humanity had of Pluto was a blurry smudge, an indistinct dot that barely hinted at its secrets. Fast forward to 2015, and all of that changed. Thanks to NASA's New Horizons probe, we now have a front row seat to one of the most breathtaking chapters in space exploration. For the first time, we saw Pluto's icy mountains, sprawling nitrogen glaciers, and a massive, heart-shaped feature that seemed to pulsate with mystery. These weren't just pictures, they were revelations that completely transformed how we view the outer reaches of our solar system. But New Horizons didn't stop there. After its historic flyby of Pluto, the spacecraft set its sights even further, toward a strange, reddish object lurking deep within the Kuiper Belt. Its name is Arrokoth, and it's unlike anything we've seen before, a flattened, two-lobed body that's more than just a frozen relic. Arrokoth is a cosmic time capsule preserving the secrets of our solar system's formation billions of years ago. What exactly did New Horizons uncover about these distant worlds? How have these discoveries reshaped our understanding of the cosmos? Stay with us as we unravel the mysteries of Pluto and Arrokoth, one discovery at a time. A mission beyond the edge of the solar system. In 2015, NASA's New Horizons mission forever changed the way we understand the outer reaches of our solar system. After a groundbreaking 9-year journey through the vast expanse of space, the spacecraft delivered unprecedented images and data that left scientists and enthusiasts alike in awe. For the first time, we saw Pluto not as a distant blurry dot, but as a vibrant and dynamic world with icy plains, towering mountains, and an atmosphere far more complex than we ever imagined. But the mission didn't end there. New Horizons ventured even deeper into uncharted territory, setting its sights on Arrokoth, a peculiar object in the Kuiper Belt that defied all expectations. What did the spacecraft uncover about Pluto's alien landscapes? And what secrets does Arrokoth, with its unique two-lobed structure, hold about the early days of our solar system? You're watching The Mysterious. Stay with me as we explore the incredible discoveries of New Horizons, revealing the untold stories of Pluto and Arrokoth. Pluto's incredible encounter. Pluto, once the enigmatic underdog of our solar system, captured the world's imagination when New Horizons revealed it in all its glory. The dwarf planet, situated in the distant Kuiper Belt, is a frozen, rocky world that spent much of its time dismissed as insignificant. Often overshadowed by larger celestial bodies, Pluto was once regarded as a mere icy outlier, too remote to hold much scientific value. Yet, its designation as the last of the traditional 9 planets to be explored ensured it held a special place in space exploration history. New Horizons changed everything. Launched in 2006 as part of NASA's New Frontiers program, this mission was designed to reach Pluto as quickly as possible, breaking records in the process. As the fastest spacecraft ever launched, New Horizons reached speeds of 58,536 kilometers per hour, completing a journey to the moon in just 9 hours, a feat that took the Apollo missions nearly 4 days. Its groundbreaking velocity wasn't achieved by speed alone. The spacecraft utilized a gravity assist from Jupiter, a slingshot maneuver that shaved 3 years off its journey. Along the way, it tested its systems by capturing stunning images and videos of Jupiter and its moons, proving its readiness for the monumental task ahead. By 2015, after nearly a decade in space, New Horizons began its approach to Pluto. As it drew closer, anticipation grew, fueled by the daily images sent back to Earth. These images revealed glimpses of Pluto's surface, each one sharper than the last, building a collective sense of awe and curiosity. The spacecraft's cameras first teased Pluto's distinct geological features, hinting at the diversity of its landscape. Among the revelations was the stark contrast between Pluto and its largest moon, Charon, which appeared much darker and less reflective. Then, on July 14, 2015, New Horizons executed its historic flyby, coming within just 12,500 kilometers of Pluto's surface. What it revealed was beyond anything scientists had imagined. Pluto wasn't just a cold, desolate rock. It was a dynamic world teeming with unexpected features. Glaciers of nitrogen ice stretched across the surface, slowly flowing like rivers of glass. Towering mountain ranges made of water ice rose several kilometers high, their jagged peaks glinting in the dim sunlight, and at the heart of it all was Sputnik Planitia, the now famous heart-shaped ice plain that captured the world's imagination. This Texas-sized feature, starkly contrasted against its surroundings, turned out to be a vast expanse of nitrogen ice. Remarkably, it showed no craters, suggesting it was geologically young and actively renewing itself. The plain was divided into polygonal cells, thought to be convection cells caused by the sublimation of nitrogen ice. Around its edges, glaciers poured into gaps between mountains, evidence of a dynamic and ever-changing surface. The flyby of Pluto was a monumental moment in space exploration, proving that even the most remote and overlooked worlds could hold secrets that challenge our understanding of the cosmos. New Horizons had revealed not just a distant world, but a vibrant and complex system, sparking a renewed interest in the mysteries of the Kuiper Belt. The Mysteries of Pluto uncovered the flyby of Pluto by New Horizons. In 2015, unveiled a wealth of discoveries that completely transformed our understanding of this distant dwarf planet. Among the most striking features was the presence of nitrogen ice glaciers, flowing across its surface like slow-moving rivers. These glaciers, particularly evident around Sputnik Planitia, defied expectations of a geologically dead world. Nitrogen ice, at Pluto's frigid temperatures of -229 degrees Celsius, behaves much like water ice does on Earth, flowing and reshaping the landscape over time. These dynamic flows provided undeniable evidence that Pluto's surface is still active. Adding to this dynamic activity were cryovolcanoes like Wright Mons, towering 4 kilometers high, with massive depressions at their centers. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes spew a slurry of water, ammonia, and possibly methane, renewing parts of Pluto's surface. This geological activity suggests the potential presence of internal heat, challenging long-held assumptions that objects this far from the Sun are completely frozen. Even Pluto's atmosphere surprised scientists. Though tenuous, it consists of nitrogen, methane, and carbon monoxide gases that extend high above the surface, creating up to 20 distinct haze layers. These layers scatter sunlight in stunning ways, casting shadows of mountain peaks and adding an ethereal beauty to Pluto's stark terrain. The haze, coupled with seasonal sublimation of surface ices, creates a dynamic atmosphere that waxes and wanes over Pluto's 248-year orbital cycle. Perhaps the most intriguing finding is evidence of a subsurface ocean beneath Pluto's icy crust. Combined with its active surface processes, this raises tantalizing questions about habitability. Could this distant world harbor conditions conducive to microbial life, much like the icy moons of Jupiter and Saturn? Pluto's unexpected dynamism challenges preconceived notions of the outer solar system, hinting at a complexity we're only beginning to understand. Arrokoth, the Kuiper Belt's hidden gem. After its groundbreaking encounter with Pluto, the New Horizons mission ventured deeper into the Kuiper Belt, setting its sights on an object that would become one of the most enigmatic finds in modern space exploration. This small, reddish body, now known as Arrokoth, holds the distinction of being the most distant world ever visited by a spacecraft. At 6.5 billion kilometers from the Sun, Arrokoth is not just a frozen relic, but a window into the solar system's ancient past. The journey to Arrokoth was a remarkable feat of precision and planning. Discovered only a year before New Horizons' historic Pluto flyby, Arrokoth was identified using the Hubble Space Telescope as a promising post-Pluto target. Despite its discovery occurring long after New Horizons was launched, the spacecraft had enough fuel and operational capacity to adjust its trajectory for a close encounter. By January 1st, 2019, New Horizons made its closest approach, passing within just 3,500 kilometers of Arrokoth and capturing data that would redefine our understanding of Kuiper Belt objects. At first glance, Arrokoth stunned scientists with its peculiar shape and composition. Unlike anything seen before, Arrokoth consists of two distinct lobes connected by a narrow neck, forming what is known as a contact binary structure. This odd, flattened shape suggested that its formation was a gentle process. The two lobes, named Ultima and Thule, likely coalesced slowly in the early solar system, preserving their integrity without the violent collisions typical of inner solar system bodies. The lack of visible fractures or stress marks further supports the theory of a gradual, low-speed merger. Adding to its uniqueness, Arrokoth's surface is a striking reddish hue, a characteristic that distinguishes it from the gray and darker tones of asteroids found closer to the Sun. This coloration is attributed to the presence of tholins, organic compounds formed through the interaction of simple molecules like methane and ammonia with ultraviolet sunlight and cosmic rays. Tholins give Arrokoth its vibrant reddish tint, much like similar compounds found on Pluto and Saturn's moon Titan. This discovery reinforces the idea that complex organic chemistry is a common feature in the outer solar system. Arrokoth's surface also reveals its role as a pristine time capsule from the early solar system. Unlike heavily cratered asteroids and moons, Arrokoth shows minimal evidence of impacts, likely due to the low collision speeds typical of the distant Kuiper Belt. This absence of significant cratering means that Arrokoth has remained largely untouched for billions of years, preserving its original structure and composition. Such a well-preserved state offers an unparalleled opportunity to study the conditions and processes that existed during the solar system's formation. Another fascinating feature of Arrokoth is its flatness, a characteristic that puzzled scientists. Early models suggested it might have formed as a more spherical object, but the data revealed that both lobes are distinctly flattened. This could be the result of centrifugal forces during its formation or long-term exposure to solar heating, which might have caused volatile materials to escape preferentially from one side, gradually altering its shape. While Arrokoth's surface composition and structure have provided invaluable insights, mysteries remain. The presence of methanol and other yet unidentified compounds in its spectra points to the possibility of unique chemical processes occurring in the Kuiper Belt. Additionally, bright regions on its surface, particularly around the neck connecting its lobes, suggest intriguing localized phenomena. These areas may accumulate volatile ices or represent regions where material has slid into the connecting zone due to Arrokoth's low gravity. Arrokoth's preservation, and peculiarities make it a scientific treasure trove. Its contact binary structure hints at the gentle, early dynamics of planetesimal formation, offering a glimpse into how larger bodies, like planets, might have come together. Its composition of tholins and other organics raises questions about the prevalence of such chemistry in the outer solar system and its potential role in seeding the building blocks of life. As New Horizons departed Arrokoth, it captured one final image of the object silhouetted against the distant stars, a poignant reminder of how far humanity has come in its exploration of the cosmos. Arrokoth, with its strange beauty and untold stories, remains a testament to the mysteries waiting to be uncovered in the farthest reaches of our solar system. Through its study, we are piecing together the story of our origins, one discovery at a time. Broader implications and future missions. The discoveries made by New Horizons have reshaped our understanding of the solar system's outermost regions, providing unprecedented insight into the distant and mysterious Kuiper Belt. Before the mission, objects like Pluto and Arrokoth were little more than theoretical curiosities, presumed to be frozen and geologically inactive. But the flybys of these worlds have revealed dynamic, evolving environments, places shaped by complex processes that defy expectations. The nitrogen glaciers and cryovolcanoes of Pluto demonstrate that even at the edge of the sun's influence, celestial bodies can be active and surprisingly young. Pluto's potential subsurface ocean and its unique atmosphere suggest that life-sustaining conditions could exist far beyond the traditional habitable zone. Meanwhile, Arrokoth's pristine, contact binary structure and reddish tholin-coated surface provide a snapshot of the solar system's early days, preserving a record of its formation. These findings hint that the Kuiper Belt may be teeming with objects that hold vital clues to the history and evolution of our cosmic neighborhood. Looking ahead, the New Horizons spacecraft still has much to offer. Even after traveling more than 7 billion kilometers from Earth, it remains operational with its radioisotope thermoelectric generator, RTG, providing power and 11 kilograms of fuel still in reserve. This leaves the mission team with an exciting question. What's next? One possibility is that New Horizons could continue its exploration of the Kuiper Belt. Although identifying suitable targets within its trajectory is challenging, the Kuiper Belt remains a largely uncharted region of the solar system. If another object is found within range, New Horizons could perform a third flyby, expanding our understanding of these distant worlds. Even a brief encounter could reveal crucial information about surface composition, structure, and the broader dynamics of the Kuiper Belt. Alternatively, New Horizons may pivot toward becoming a versatile observatory for astrophysical studies. Positioned far beyond the planetary region of the solar system, it could provide unique perspectives on celestial phenomena. For example, it could observe distant planets like Uranus and Neptune, offering views unobtainable from Earth. It could also study the faint optical and ultraviolet light of extragalactic space, contributing to our understanding of the universe's large-scale structure. Beyond observational studies, New Horizons could also investigate the heliosphere, the vast bubble of solar wind that envelops the solar system, and the interstellar medium beyond. In the 2030s, the spacecraft is expected to leave the heliosphere, much like the Voyager probes before it. At that point, it could study the boundary between solar and interstellar space, offering new insights into how our solar system interacts with the galaxy around it. New Horizons' achievements already represent a monumental leap in our exploration of the Kuiper Belt and the outer solar system. Its data has challenged long-held assumptions and raised new questions, such as the prevalence of subsurface oceans, the nature of cryovolcanism, and the chemistry of tholins in the outer reaches of the Sun's influence. As we continue to sift through the data from New Horizons and plan for its future, one thing is clear. The spacecraft has proven that the distant frontier of our solar system is not a barren wasteland, but a region rich with dynamic processes, ancient secrets, and the potential for groundbreaking discoveries. Whether it uncovers new targets or becomes a deep space observatory, New Horizons' journey is far from over, and its legacy will inspire generations of exploration to come, unveiling the distant frontiers of our solar system. From Pluto's icy plains and towering cryovolcanoes to Arrokoth's strange flattened shape, the New Horizons mission has revealed an unseen side of our solar system, sparking countless new questions about the worlds beyond. These discoveries have transformed our understanding of the Kuiper Belt and offered us a glimpse into the early days of the solar system's formation. If you enjoyed this deep dive into the wonders of the Kuiper Belt, be sure to check out my other videos on groundbreaking space missions and the latest discoveries in astronomy. Don't forget to like, subscribe, and share to help others join the journey of cosmic exploration. Thanks for watching, and as always, stay curious about the cosmos. Who knows what incredible discoveries await us in the farthest reaches of space? See you next time.